Okay, so today what we're going to talk about in this lesson, we're going to start with energy. Does anybody know any types of energy? Go ahead, Anston.
Electrical.
Electrical energy. Elliot?
She took mine.
She took yours? Well, let's look around. What do you see here that might be a form of energy?
The light bulb.
Okay, the light bulbs. So what about the light bulbs? What type of energy do you think that's called? Elliot? Do you have
Electrical.
not electrical, the lights themselves, what would that be called?
Electricity.
No, you're close. Okay, since we're talking about the light bulbs, that's called, some people call it light energy, but it's radiant energy. Okay?
Radiant energy.
So there's several different types of energy. We've got electrical, which you said, radiant. We've got thermal energy.
Thermal energy.
Thermal energy. We have chemical energy. What else is there? We could go as far as to say we have nuclear energy, mechanical or kinetic energy. Do we know what mechanical or kinetic means?
No.
So that's when something is movement. We talk about kinetic energy. So if we were to turn on this fan, like this, what did we just do?
Turn it on.
We turned what type of energy? What powers that fan? What type of energy powers the fan? Electrical, right? It takes electricity. So we just powered this fan using electrical energy. We turned that into kinetic energy to turn the fan. So that's what we're going to be discussing is energy transformation. So now we talk about what types of energy that we know about. Let's give a few more examples of the energy. So what would a battery be, Elliot?
Something that charges another thing.
Yes, it's something that charges another thing. What type of energy do you think it would be?
Electrical.
Yeah, we could say it's electrical. DC batteries, they are definitely a power source, an electrical source. They're also a chemical source because they have a chemical makeup in them, in the alkaline batteries, that cause them to actually create energy in the little battery. So that's a type of chemical or electrical. What was radiant? Do you remember what radiant was?
Radiant? I think it was moving.
Not moving. What were we talking about? If something's radiant, it shines, it glows.
Like the fan.
The light bulbs is what we're
Light
looking for. What else do we notice about light bulbs? Have you ever been close to one?
They're warm.
They're warm. So what would that energy be? We talked about a thermal energy, correct?
Yes.
There we go. Electrical, we already know. Most things in a house start with electrical energy. So all of our appliances, our stoves, our refrigerators, our microwaves, our lights, but they typically get turned into a different. So they transform the electrical energy into that. So now that we've covered that, so let's start with what we're going to focus on throughout this lesson. It's going to be a transformation of energy, but we're going to go with batteries, which you're all familiar with. What are some things that use batteries? Go ahead, Anson.
Cars.
Cars. Elliot? What's something that you guys have that use batteries?
Tablets.
Tablets use a rechargeable battery, Anson.
Toys.
Toys. That's the biggie that most of them, right? What do we notice about a lot of the batteries in toys? Does everything run off one battery?
No, not all the time.
No? So what do we have?
Sometimes they have like 4 batteries.
Sometimes they have multiple batteries. Yep. So why do you think that is? That some things take the same amount of batteries and some take multiple batteries?
So, because some need more energy?
Some need more energy. That's true, yeah. It takes more power to run certain things, correct?
Mm-hmm.
Okay. So, and how do they get that power? How do they get more power? You've already stated that. I just want to make sure you clearly understand it. How do they get more power? No, you've already stated that some take multiple batteries, correct? So multiple batteries in what's called a series, you add up the power. So for example, we'll pull this up real quick just so you guys understand. This is a 6 volt and a 6 volt. So when you put them together, you're going to have more energy, okay? You can add up the volts. So a 6 volt will become a 12. So on the double A's, they're 1.5. So when they add up, you will add 1.5 for each battery. So this is why they take multiple batteries at times. Okay? So with that being said, what we're going to do in this activity is I want you guys, what we're going to do is create a simple circuit. And what we're going to try and show is that we're going to take a DC battery. Do we know what DC is, by the way? Nobody has. Do we use DC in our houses, or do we use, is there another type? Do you know what the name of the other type of energy is?
No.
There's AC. Okay? DC is direct current. AC is alternating current. DC is typically from batteries. Okay? And alternating current is typically what's in your houses and schools and everything else.
Is that why when you turn the temperature up, it's called an AC?
No, that's actually for air conditioner. But you know, that's good though. Now you're asking questions. Now we're probing from where you've heard that before. So that's really good. So what we're going to do is try to make a simple circuit, and we're going to take the DC and we're going to turn that into another type of energy. So we're going to transform what type of energy did we say that a battery was, Elliot?
An electrical.
Or, what was another one? Answer, if you know it, you can say it.
Because I know it, I just can't.
Okay. If we're mixing things together in that battery to make sure we have the proper makeup to give electrons and protons, what did we call it? Chemical energy?
Yeah.
So it can be classified as both an electrical and a chemical energy. So what we're going to do, these are going to be your components. 6-volt battery. We're going to have these wires to make it easy. We're going to use these alligator clips so it's easier. So we have your wires here to make your circuit. And then what we're going to do is we're going to have a light bulb. Okay? These are going to be the components we're going to use to discuss our energy transformation. So with that being said, as we talked about, does anybody have, before we move on, any idea as to what energy is going to be here and what we're going to convert it to, just by looking at the components? Go ahead.
The light bulb and the electrical energy.
Not the light bulb. What would be, that would be electrical or chemical. So what would it transform to? If we use that chemical energy and or electrical energy, what would it transform into? What would be the resulting energy, Elliot, if we can make a circuit for that light to come on? Say again? No, we're not adding up the voltage. What type of energy will we transform this chemical energy to? What did we say that lights are? What type of energy? We had a name for it. We had a name for it.
They were like,
yes, what was the word for that? What does someone say when you're glowing and you look beautiful? There's another word they use, begins with an R.
Radiant.
Radiant energy. So that's what we're going to do. But before we do that, you all are going to have to draw a circuit on a sketch first. We're going to have to verify and see that your sketch is actually going to work. And then what we'll do in the end is we will test your sketch to make sure that you truly understand how this works. Does everybody know one final thing before we finish up here and move on? Do you understand, anybody understand the two sides of the battery? Anson, you did a 4-H project. Would you remember what there was with batteries? There were two sides. You You had to have,
Positive and negative.
there you go. You understand that, Elliot? That you have to have a positive and a negative. You have to have a place for electrons to flow to and from, correct? Alright, well, we'll get started.